Welcome to Tech Explained. Today, we're covering CCSP Domain 1.
That's right. We're really getting into the fundamentals today.
It's the foundation, the essential building blocks,
Sure.
drawn from the core concepts of cloud computing, architecture, and design.
Exactly. It's not about the super specific tech just yet.
Right. It's more about really understanding the lay of the land, what cloud actually is, how it's structured, and maybe most importantly, who's ultimately responsible for securing things when you move your data and systems somewhere else.
That responsibility piece is huge.
Our mission today is to unpack these fundamental ideas. We want to help you understand the core principles that underpin cloud environments, especially, from a security perspective. It's about grasping the characteristics that define cloud, the models that dictate how it's delivered and deployed, the critical roles involved.
Security and risk management change, because they do change significantly.
Definitely. Especially when you're not managing all the infrastructure yourself. We'll touch on evaluating services, looking at the business case, and the frameworks that can guide you.
Lots to cover, but it's all interconnected.
The goal is to make these foundational concepts clear, practical, and, maybe even a little surprising sometimes. We're aiming for those aha. Really solidify your understanding of why cloud security isn't just, traditional IT security done remotely.
Yeah.
It really has its own unique dynamics.
You've hit the nail on the head. These foundational concepts are paramount. Think of them as the vocabulary and grammar you need to speak the language of cloud security fluently.
Okay, the basic building blocks.
Right. Without a solid understanding of what cloud computing fundamentally is, the different ways it can be structured, and critically, where the ultimate responsibility for security lies, it becomes incredibly difficult to effectively evaluate risks, implement controls, and make sound decisions in a cloud environment.
You're kind of flying blind otherwise.
Pretty much. Whether you are navigating cloud adoption within your organization, maybe preparing for a certification, or simply trying to be better informed in today's technology landscape, this fundamental context is indispensable. It equips you with the perspective needed to ask the right questions of providers, understand where your security focus needs to be, and build effective security programs.
So it's really the starting point for everything else.
It absolutely is. Okay, let's unpack this.
Let's do it. So let's start with the big one. What is cloud computing? It's a term we hear constantly, but getting a really precise, universally agreed upon definition can feel surprisingly elusive.
You're absolutely right. It's one of those concepts that's more easily recognized by its properties than, neatly defined in a single sentence.
Right.
Well, there's that popular saying, there is no cloud, it's just someone else's computer.
Yeah, I've heard that one.
That's an oversimplification, though it captures the essence of the public cloud model fairly well. In public cloud, you are using computing resources hosted and managed by a large provider.
Okay.
But as we'll see, private cloud doesn't necessarily fit that description, especially if you own the hardware yourself.
Right. Good point.
And often when you interact with cloud services, you're using a web-based application or service where the underlying infrastructure is completely hidden from you. You're not thinking about servers or storage at all.
You're just using the app, like email or something.
Exactly, just accessing functionality. Now, there's an official ISO definition out there, but frankly, it's quite academic.
Dry.
Very dry. And it doesn't provide the practical understanding that's truly helpful. It's not the kind of definition that sticks with you or really illuminates the core value proposition of cloud.
So if a single definition is tricky, how do we get a practical understanding? If a service has these traits, you can comfortably call it cloud.
Precisely. Defining cloud computing by its essential characteristics is a much more practical and useful approach. These traits are what differentiate cloud services from, say, traditional IT hosting or managed services.
Okay, so these are the defining features.
If a service exhibits these properties, it embodies the cloud model. And understanding these characteristics is fundamental because they explain why cloud computing offers the benefits it does, and importantly, why it introduces different security considerations.
Got it. Makes sense.
Let's walk through them.
All right. First up is on-demand self-service. This sounds incredibly convenient, but what does it mean in a practical sense for someone using cloud resources?
It means that you, as the cloud consumer, can provision computing capabilities, could be server instances, storage volumes, network resources, even specific applications automatically.
Without talking to anyone.
Exactly. Without requiring human interaction from the cloud service provider. You log into a portal or use an API, select what you need, and typically within seconds or minutes.
Wow, seconds.
Often, yeah. Those resources are allocated to you and ready to use.
That's a world away from old school IT requests.
Oh, absolutely. Contrast this with requesting IT resources in a traditional data center environment even just a decade or two ago. That might involve submitting formal requests, getting managerial approvals,
Forms?
waiting for procurement to order hardware, waiting for that hardware to be physically installed, configured, and racked. The whole process could take weeks or even months.
Yeah, I remember those days.
On-demand self-service just collapses that timeline dramatically.
So it enables speed.
Massive speed. It's a huge enabler for agility, innovation, and rapid development. Developers can spin up test environments instantly. Businesses can deploy new services in hours instead of months. It allows for experimentation.
Yeah, think fast, I guess.
Definitely. And the ability to scale up for a project and then tear down the resources just as quickly if it doesn't pan out, saving costs.
That speed sounds like a superpower for a business, but you mentioned there's a dark side to this self-service model.
Yes, the flip side of such easy, rapid provisioning is the potential for shadow IT.
Ah, okay. Tell me more.
This occurs when departments or individual users bypass the central IT organization to directly acquire and manage cloud services because it's so easy to sign up with a credit card and start using a service.
IT might not even know it exists.
Exactly. IT may not be aware of these deployments, and these shadow IT environments often lack the necessary security controls, oversight, and compliance adherence that central IT would enforce.
So security gaps, compliance issues.
Huge potential issues. It can lead to data sprawl, security vulnerabilities, unmanaged access, and compliance risks that the organization is completely blind to yet remains accountable for. So while self-service is a huge benefit, it requires strong governance to manage effectively.
Got it. Convenience needs control. Okay, the second characteristic is broad network access. This one feels pretty intuitive, doesn't it?
It is, relatively speaking. Broad network access simply means that the cloud services and resources are available over the network using standard mechanisms, primarily the internet.
So basically anywhere you have internet.
Pretty much. And accessible from diverse client platforms. Think about how you access most cloud services today through a web browser on your laptop, tablet, or smartphone.
Right, from any device.
This characteristic ensures that as long as you have an internet connection and a compatible device, you can access your cloud-based applications or data. It removes the limitation of needing to be on a specific corporate network or using a particular type of device. It's about ubiquitous availability over standard interfaces.
Makes sense. Next is resource pooling. This one seems really central to the efficiency cloud provides. What exactly are these resources, and how does pooling work?
This is indeed a core economic and operational characteristic of cloud. When we talk about resources, in the fundamental sense, we mean compute processing power.
Okay, CPU cycles.
Storage, data retention.
Disk space.
And network, data transfer and connectivity.
Bandwidth connections, got it.
Resource pooling means that the cloud provider's computing resources are pooled together in large, shared, multi-tenant data centers. These massive pools of servers, storage devices, and network equipment serve multiple consumers simultaneously.
So everyone shares the big pool of hardware.
Right. The provider aggregates these resources and then allocates them dynamically to individual customers based on their needs.
How do they keep everyone separate and secure then?
The magic that enables this effective pooling and sharing while keeping customers isolated and secure is virtualization.
Okay, virtualization.
Instead of giving you a specific physical server, the provider gives you a virtual machine, VM, that runs on some physical server in the pool. You get a virtual disk that lives on some shared storage array. You get a virtual network interface connected to some shared network fabric.
So you don't touch the physical hardware directly.
Correct. The underlying physical hardware is abstracted away. Virtualization allows the provider to efficiently utilize their physical hardware by running multiple virtual instances from different customers on the same physical machine.
Better utilization for them.
And it also allows them to dynamically move your virtual resources to different physical hardware in the pool for maintenance, load balancing, or redundancy without you even noticing.
So the pooling enabled by virtualization, is what makes that rapid scaling possible, right? You're not waiting for new hardware. You're just being allocated a slice from the existing massive pool.
Exactly. Resource pooling is the foundation that directly enables the next characteristic, rapid elasticity. Because there's a vast pool of resources abstracted by virtualization, the provider can quickly allocate more resources to you when your demand spikes.
Or less if you don't need them.
Or reclaim them from you when your demand decreases.
Okay, so if pooling makes resources available, what happens when your website traffic suddenly triples? Or a batch job needs way more processing power than usual? Or maybe you finish a project and no longer need all those temporary resources.
That's where rapid elasticity comes in. It's the capability to quickly scale your provisioned resources both upward and downward, often automatically and seamlessly based on demand.
So it stretches and shrinks as needed.
Precisely. This is incredibly powerful. If you need to double your web server capacity for a Black Friday sale, you can provision those extra virtual servers in minutes. Need an extra petabyte of storage? It's available almost instantly.
And just as importantly,
when the sale is over or the project is done, you can deprovision those resources just as quickly.
So you're not paying for things you don't need.
Exactly. This elastic scaling means you don't need to over-provision hardware up front in your own data center to handle peak loads that only happen occasionally. You can design your systems to automatically scale based on metrics like CPU utilization or network traffic, and the cloud provider's infrastructure handles the dynamic allocation from the shared pool.
Which leads us directly into the final standard characteristic, measured service. It definitely sounds like it's all about how you get billed.
It absolutely is. Measured service means that the cloud provider closely monitors, controls, and reports on your usage of the cloud resources. They have systems in place to meter exactly how much compute time you use,
how much data you store,
how much network traffic leaves their network, how many requests your database handles, and so on. It's very granular.
So you pay for what you use.
Right. The business model is fundamentally consumption-based. You pay only for the resources you actually consume. This shifts the cost model significantly compared to traditional IT, where you buy hardware and pay for power and cooling, whether you use it at 10% or 90% capacity.
So it gives you transparency too.
Yes, measured service provides transparency. You can see detailed breakdowns of where your cloud spending is going, which can help you optimize usage and costs. It turns IT spending from a fixed capital cost, largely based on potential capacity, into a variable operational cost based on actual usage.
Okay. The material also mentions one more characteristic that's present in most, but not all, cloud environments, especially public cloud.
Yes, that's multi-tenancy. As we touched on briefly when discussing resource pooling, multi-tenancy means that multiple customers of the cloud provider are sharing the same underlying physical infrastructure, the same physical servers, storage arrays, network devices.
So multiple tenants in the same building, essentially.
Kind of, yeah. But critically, they are logically separated through virtualization and other mechanisms to ensure one tenant's data and operations are isolated and secure from another's. But the physical hardware is shared.
And that's key for cost.
It's a key reason why public cloud is so cost-effective. The provider achieves massive economies of scale by spreading the cost of the physical infrastructure across thousands or millions of customers.
What's the exception then?
The exception to multi-tenancy is a private cloud. By definition, a private cloud is dedicated to a single customer, so they are not sharing the underlying infrastructure with others.
So private cloud isn't multi-tenant?
Correct. Because private cloud exists and is still considered cloud, multi-tenancy isn't a universal defining characteristic, but it's certainly a fundamental aspect of the public cloud model, which is, the most common form.
Okay. Those characteristics paint a very clear picture of what cloud computing is fundamentally built upon. Now that we understand the what, let's shift gears and talk about the who.
This point cannot be stressed enough. When you adopt cloud services, you are effectively outsourcing components of your IT infrastructure and operations to a third party, the cloud service provider.
Right, you're handing stuff over.
And this changes the dynamic significantly, particularly from a security and governance standpoint. You are relying on the provider to manage certain aspects of security for you and clarity on who is doing what is essential.
So who are the main players?
At the highest level, we have two fundamental roles: the cloud consumer and the cloud service provider.
Okay, consumer and provider.
The cloud consumer is the organization or individual that utilizes or accesses the cloud services. That's you if you're using AWS, Azure, Google Cloud, or any SaaS application. You are consuming the service.
Makes sense.
The cloud service provider is the organization that owns, operates, maintains, and provides the cloud infrastructure and services to the consumers. These are the companies building and running those massive data centers and offering IaaS, PaaS, or SaaS.
The big names we usually think of.
Usually, yes.
Now, why is this difference so crucial in the cloud context, particularly for the consumer?
This distinction is arguably the single most vital concept in understanding cloud security from a consumer perspective. It defines who ultimately answers if something goes wrong.
Okay, ultimate ownership.
Yes. Let's use the analogy provided. Accountability is about ultimate ownership and answerability. It's the blameworthiness, the throat that gets choked in the worst-case scenario. The absolute key insight here is that accountability can never be delegated.
Never.
Never. You cannot give away your ultimate responsibility for something.
So even if you move your data to the cloud.
Right. If your organization decides to store its sensitive customer data in the cloud, your organization, the cloud consumer, remains accountable for the security and privacy of that data. Full stop.
What happens if there's a breach then?
Well, if there's a data breach, the cloud provider might be found responsible for failing to implement controls that led to the breach. But your organization is still accountable to its customers, regulators, and stakeholders for the loss of their data. The CEO isn't going to call the cloud provider's CEO to account for your data breach in the same way they would call your chief security officer.
That's a really clear distinction. So accountability stays put. What about responsibility?
Responsibility, on the other hand, can be delegated. The responsible party is tasked with performing the actual work, implementing, operating, and enforcing specific controls and tasks based on the direction or requirements set by the accountable party.
So you can delegate the doing, but not the owning.
Exactly. In the cloud, this leads to the concept of the shared responsibility model.
Okay, I've heard of that.
The cloud service provider is responsible for the security of the cloud, the physical infrastructure, the network, the hypervisor, the virtualization layer. That's their job.
Right, the stuff they own and run.
But the cloud consumer is responsible for security in the cloud, the operating system of a virtual machine, in IaaS, the applications running on it, the configuration of security groups and firewalls, and crucially, the data itself.
So the customer still has a lot of responsibility.
Absolutely. Even though the provider is responsible for implementing many security controls related to the underlying service, the consumer is always accountable for ensuring that their data and systems are adequately protected using the tools and configurations provided by the provider and for ensuring they meet their compliance obligations. As the summary puts it, customer, accountable, provider, responsible for implementing parts of the security controls, often described as security of the cloud.
Customer accountable, provider responsible for their part. Got it. That distinction is incredibly important. It's not out of sight, out of mind when you move to the cloud. Your accountability follows your data. Beyond the consumer and provider, other players in the ecosystem, like brokers. What roles do they play?
Cloud brokers act as intermediaries. They sit between the cloud consumer and one or more cloud service providers, offering value-added services or managing the relationship.
Like a middleman.
Sort of, yeah. They might help consumers choose the right provider, manage multiple cloud services from different vendors, or add capabilities on top of the standard cloud offerings.
Were there different types?
Yes. 3 specific types of broker roles to understand. First, aggregation.
Okay.
An aggregation broker takes services from multiple cloud providers and combines them into a single integrated composite service for the customer. This simplifies management for the consumer who might need components from different vendors.
Bundling things together.
Essentially. Second, arbitrage.
Arbitrage, like in finance.
Similar idea. This is where a broker dynamically switches between cloud providers based on criteria like cost or performance. They might move a workload from one provider to another because provider A is cheaper this month, or provider B offers lower latency for a specific region. They optimize the consumer's usage across different providers.
Interesting. Actively managing the provider mix.
Right. And third, intermediation.
Okay.
An intermediation broker enhances an existing cloud service by adding value on top of it. This could be adding extra security services like advanced threat protection, providing enhanced monitoring and reporting, or offering specialized identity and access management capabilities that aren't part of the standard provider offering.
So adding extra features or security layer.
It's a list, but it helps clarify the diverse tasks involved.
Exactly. These are functional descriptions of roles you might find within an organization or service provider that work with cloud technologies. Understanding them helps to delineate who might be performing specific tasks related to cloud development, administration, and management. It shows it's not just one vague cloud person.
Right, so who are they?
Well, we have cloud developers who are building the applications and infrastructure components that run in the cloud, leveraging the provider's tools and services.
The builders?
Then cloud administrators are the day-to-day operators. They test and monitor cloud services, manage user access, handle security configurations, provide usage reports, and troubleshoot problems.
Keeping the lights on, virtually speaking?
Pretty much. A cloud service manager is focused on the overall provisioning and delivery of cloud services to users, overseeing their life cycle and ensuring they meet operational requirements.
More of a service delivery focus.
Yes. The cloud service business manager looks at the cloud services from a business perspective. They gather metrics on usage and cost, manage deployments, and define the processes and environments used for bringing services online, aligning IT with business goals.
Connecting IT to the business needs.
Correct. The cloud service deployment manager often handles the contractual and administrative side, dealing with billing from providers, managing the customer relationship with the provider, handling procurement of cloud services, and assisting with audits requested by the provider or external auditors.
The business and admin side of dealing with the provider.
Right. A cloud service integrator is key when an organization has existing on-premise systems that need to connect and interact with cloud services. They build and manage those hybrid connections and ensure data flows correctly between environments.
Bridging the old and the new.
You could say that. And finally, a cloud regulator is responsible for ensuring compliance, security, and operational standards are met within the cloud environment, whether from a provider or a consumer perspective, often dealing with external legal and regulatory requirements.
The compliance watchdog.
In essence. So while a cloud consumer and cloud service provider are the high-level players, these specific roles illustrate the breadth of tasks and expertise required in a complex cloud environment, reinforcing that it's not just one person doing everything.
Right. It takes a village, even if that village is spread across provider and consumer organizations.
Yeah.
Now that we have a handle on what cloud is and who's involved, let's talk about how these services are packaged and delivered. The sources introduce the major cloud service models.
Cloud service models are essentially different layers of abstraction offered by providers. They give consumers varying levels of control over the underlying infrastructure and, importantly, different points of responsibility.
So different ways to buy cloud services.
Exactly. You can visualize them as layers in a stack, building upwards from the physical hardware. The three main foundational service models are infrastructure as a service, platform as a service, PaaS, and software as a service, SaaS.
SaaS. Okay, let's start at the bottom. IaaS.
Right. At the bottom layer, providing the most control to the consumer, is infrastructure as a service. This is where the provider gives you virtualized fundamental computing resources. Virtual servers, virtual storage, virtual networks, virtual firewalls.
Like building blocks.
Essentially, yes. You are given a virtual data center. As the consumer, you are responsible for managing everything from the operating system upwards, installing patches, configuring security settings, installing applications, managing user access within your virtual environment, and managing your data.
So you manage the OS and everything on top.
Correct. The provider is responsible for the physical hardware, networking, and the hypervisor that creates the virtual environment. It's the closest model to managing your own data center, but using virtual resources provided by someone else.
Okay, maximum control, maximum responsibility for the customer, above the virtualization layer. What's next? PaaS.
Moving up, we have platform as a service, PaaS. With PaaS, the provider manages the underlying infrastructure and the operating system, middleware, and runtime environment.
Like databases, web servers.
Exactly. Databases, web servers, programming language runtimes. As the consumer, your focus shifts primarily to developing, deploying, and managing your applications and data.
So you just worry about your code and data.
Largely, yes. You don't worry about patching the OS or maintaining the database software. The provider handles that. This model is ideal for developers who want to focus on writing code rather than managing infrastructure.
Less control than IaaS, but easier for development.
Right. You gain significant operational simplicity for application development.
And at the top?
At the top is software as a service, SaaS. This is the most abstracted layer. The provider manages the entire stack, the infrastructure, platform, and the application itself.
Everything. As the consumer, you are simply using the software application. typically accessed via a web browser or a client application over the internet. Think of your web-based email, online CRM systems, or collaboration tools.
Like Office 365 or Gmail.
Perfect examples. You don't manage anything about the software or the underlying systems, you just use it. You have the least amount of control here, but also the least management burden. You're essentially renting access to a finished application.
So IaaS is like renting the land and utilities, PaaS is like renting a workshop with tools, and SaaS is like renting a finished office suite.
That's a pretty good analogy, actually. And the lines between these can sometimes blur, and newer models have emerged, like containers as a service, CARAs, and functions as a service, FAS or serverless computing, which offer even more fine-grained abstraction, typically fitting between IaaS and PaaS respectively, taking on even more management responsibility for the provider.
So even more specialized layers.
Yes. And as you look across the cloud landscape today, you see an explosion of databases as a service, network as a service, NAS, monitoring as a service, MAS, security as a service, SACOS. The list is constantly growing as providers offer more and more specialized functions as managed services.
Wow, there's an as a service for everything.
Almost. But understanding IaaS, PaaS, and SaaS provides the essential framework for categorizing most cloud services.
So the service models define what is delivered and what the consumer manages. But there's also the question of where the infrastructure lives and who owns it, the deployment models.
Right. Deployment models describe how the cloud infrastructure is managed and where it resides, defining the scope and accessibility of the resources. They answer the question, who owns, manages the hardware, and who can access it?
Okay. What are the main ones?
The most common is public cloud. This is the quintessential someone else's computer model we talked about. The infrastructure is owned and operated by a cloud service provider like AWS, Azure, Google Cloud, and resources are made available to the general public over the internet on a multi-tenant basis.
Open to anyone.
Essentially, it offers high scalability, cost-effectiveness due to shared infrastructure and economies of scale, and rapid deployment.
What about the opposite, private cloud?
Next is private cloud. This infrastructure is provisioned for exclusive use by a single organization. It is not shared with other customers.
Just for one company.
Right. Now, a private cloud can be owned, managed, and operated by the organization itself within its own data center. Or, and this is an important nuance, it could be provider-owned infrastructure dedicated to that single customer.
So the provider owns it, but only one customer uses it.
Exactly. It could potentially be hosted within the customer's data center or even within the provider's data center, but logically isolated for that customer. The key differentiator is single customer exclusivity.
Why choose private cloud then?
It often provides greater control and can help meet specific security or compliance requirements, though it typically involves higher costs and management overhead than public cloud.
Makes sense. What else?
A community cloud is shared among several organizations that have similar requirements and objectives.
Shared, but not public.
Right. These common requirements might be related to security policies, compliance mandates, like for a specific industry, say healthcare or finance, performance needs, or jurisdiction, like sharing infrastructure only within a certain country. It allows these specific communities to pool resources and share infrastructure costs while meeting their collective needs.
Okay, a shared private cloud for a specific group.
That's a good way to think of it. Then there's hybrid cloud.
Mixing public and private.
Yes. It's a composition of two or more distinct cloud infrastructures, private, community, or public, that remain unique entities but are bound together by standardized or proprietary technology that enables data and application portability. The idea is to allow workloads and data to move between environments.
So you get the best of both worlds.
That's the goal. An organization might use a private cloud for sensitive data and core business applications and leverage the public cloud for elastic web servers or non-sensitive workloads, bursting to the public cloud when demand is high. It seeks to balance control and security with scalability and cost efficiency.
And finally, multi-cloud.
Finally, we have multi-cloud. This refers to the use of multiple public cloud services from different cloud service providers.
So using AWS and Azure and Google Cloud, maybe?
Exactly. This is distinct from hybrid cloud, which mixes public and private. In multi-cloud, you might use AWS for one application, Azure for another, and a Google Cloud for a third.
Why would you do that? Seems complex.
Organizations adopt multi-cloud strategies for various reasons. to avoid vendor lock-in, to leverage best-of-breed services from different providers, to enhance resilience by not having all their eggs in one provider's basket, or to meet diverse geographic or regulatory requirements that different providers might satisfy better.
Okay, spreading the risk and optimizing features.
That's the idea.
That covers the models. Now, before an organization gets excited about all this elasticity and cost savings and jumps headfirst into cloud adoption, there are crucial shared considerations they absolutely must think about up front. Why are they called shared, and why is analyzing them before you migrate so incredibly important?
They're termed shared considerations because they often involve aspects of the cloud environment where the responsibility or resources are shared or interact closely between the provider and the customer. For instance, while the provider shares their infrastructure, the customer shares responsibility for its secure configuration and use.
Okay, involves both parties.
Right. As for why thinking about them beforehand is critical, this is a major insight. Cloud providers make it incredibly easy and fast to provision resources and move data into their cloud.
The easy button to get in.
Pretty much. What they don't always make easy is moving data out or switching providers or ensuring your systems can work together with other systems outside their environment.
The getting out part might be harder.
It often is. If you don't evaluate these factors before you commit to a provider and migrate significant amounts of data and applications, you can find yourself locked in, unable to move data easily, facing unexpected costs or technical hurdles, or realizing the service doesn't meet a critical business or regulatory requirement that you only discovered after you were already dependent on it.
So you lose leverage if you don't check first.
You lose leverage and flexibility once you're invested. This reinforces that moving to the cloud is fundamentally a business decision, not just an IT task.
Back to the business owner again.
Absolutely. The business owner of the data, application, or process being considered for cloud migration must be heavily involved in evaluating these shared considerations. They are accountable for the business outcome and the risks, so they need to understand the implications of things like data portability or regulatory compliance for their specific area.
Okay, so what are some of these critical considerations?
Let's list some of the essential ones. First, interoperability.
Making things talk to each other.
Right. The ability for different cloud services or your cloud services and your existing on-premise systems to seamlessly exchange and understand information. High interoperability means your systems can talk to each other effectively, which is vital in hybrid or multi-cloud scenarios.
Next.
Data portability. This is huge. It's the ease and ability to move your data, your files, your databases, your backups from one cloud service to another, or from the cloud back to your own data center in a usable format.
You get your data out easily.
And is it usable when you get it out? You want high data portability. Low portability is a major driver of vendor lock-in, making it costly and difficult to leave a provider, even if you find a better or cheaper option later.
Okay, related to that must be application portability.
Exactly. Application portability is the ability to move your custom software applications between different cloud environments and have them run correctly with minimal modification. Like data portability, high application portability is key to avoiding vendor lock-in for your critical business applications.
And then, reversibility. Sounds similar, but maybe more about the exit process.
It's a related critical point. It's about your ability to easily exit a cloud service and have confidence that all your data and applications can be removed, and, importantly, securely erased from the provider's infrastructure according to your agreements and security policies.
Can you truly leave cleanly?
That's the question. You need to investigate the exit strategy before you sign up.
What else should be on the checklist?
Other considerations, perhaps more familiar but still vital: availability, ensuring your data and services are accessible when needed; security, protecting the confidentiality, integrity, and availability of your data and systems in the cloud, using the shared responsibility model effectively. That's obvious but crucial.
Right.
Privacy, ensuring your use of cloud services complies with all relevant privacy laws and regulations, especially regarding sensitive personal data. This might dictate which providers you can use, or even whether you can use the cloud at all for certain data types, depending on jurisdiction and the provider's location and practices.
Huge one, especially with GDPR and similar laws.
Absolutely. Resiliency, the ability of the cloud infrastructure to withstand failures, attacks, or disasters, and continue operating or recover quickly. Performance, evaluating the speed, latency, throughput, and overall responsiveness of the cloud services for your specific workload needs.
Does it meet your speed requirements?
Basically, yes. Governance establishing the necessary policies, procedures, and oversight to manage cloud adoption and usage effectively and securely, ensuring alignment with organizational goals and risk appetite. This ties back to the roles and responsibilities we discussed earlier.
Yeah.
Service level agreements, SLAs, understanding the contractual commitments from the provider regarding uptime, performance, support, and what penalties they face if they don't meet those levels. This is your contractual recourse.
Or the provider promises, legally.
Right. Auditability, ensuring you have the necessary logs, monitoring capabilities, and reporting from the provider to demonstrate compliance with internal policies and external regulations. Can you prove what happened to your data or who accessed your systems? You need that visibility.
Proof for the auditors.
And finally, regulatory compliance, ensuring the cloud provider's service offering and your planned usage of it allows you to meet any industry-specific or geographic regulatory requirements, such as those for healthcare, finance, or government data. This is a non-negotiable requirement for many organizations.
That is a significant list and underscores why just moving to the cloud isn't a trivial decision. It really needs careful thought, ideally by the business owner alongside IT and security. It highlights the need for structured approaches, which brings us to frameworks that can help organizations navigate this complexity. What are they and how do they help?
Frameworks in this context are structured sets of guidelines, standards, best practices, and processes. They provide a systematic approach to building and managing functions, like information security, risk management, or cloud architecture, in a consistent, repeatable, and comprehensive manner.
Like a blueprint or a recipe book.
Kind of, yeah. They are incredibly useful because they condense the collective knowledge and experience of experts into a usable guide. Instead of inventing your security program from scratch, you can adopt a recognized framework that provides a proven roadmap, ensuring you don't miss critical areas.
Avoids reinventing the wheel.
Exactly. Frameworks also provide a common language and structure for communication, both internally and externally. Cloud providers, for instance, often certify their services against specific frameworks to demonstrate their security posture to potential customers.
So customers can use them to compare providers.
Yes. Customers can then use the same framework to evaluate providers and manage their own security within the cloud.
Let's look at some key ones mentioned. Starting with general security frameworks that aren't specifically for cloud but are foundational.
Okay. The most widely adopted general information security framework globally is ISO 27001.
Heard of that one. It's pretty big.
It is. It provides the requirements for establishing, implementing, maintaining, and continually improving an information security management system, or ISMS.
ISMS.
Think of an ISMS as a holistic approach to managing sensitive company information, encompassing people, processes, and technology. ISO 27001 outlines the management system requirements and references a set of control objectives and controls.
Specific security measures.
Right. Listed in its Annex A and detailed further in its companion document. These controls cover a vast array of security domains, including security policy, organization of information security, human resources security, asset management, access control, cryptography, physical security, operational security, a lot of areas.
Very comprehensive.
It covers supplier relationships too, which is very relevant for cloud. Incident management, business continuity, compliance, it's all in there.
Can you get certified for it?
Yes. A critical point about 27001 is that an organization can be certified against it by an accredited third-party auditor. Achieving ISO 27001 certification is a strong signal to customers and partners that an organization, like a cloud provider, has implemented a recognized, systematic approach to information security management.
So providers often get this certification.
Many do, and the companion document is ISO 27002.
What does that do?
This standard provides implementation guidance for the controls listed in ISO 27001's Annex A. It gives you detailed advice, recommendations, and examples on how to implement each specific control effectively.
So 27001 is the what? 27002 is the how?
That's a great way to put it. Think of 27001 as the checklist and framework for the management system, and 27002 as the how-to guide for the individual security practices. But it's important to note that you cannot be certified against ISO 27002. It's purely a guidance document.
Okay, so those are general security frameworks. Are there others specifically designed for cloud security?
Yes, recognizing the unique aspects and shared responsibility of cloud, several frameworks provide guidance tailored to cloud environments.
Makes sense. Which ones?
The CSA Cloud Controls Matrix, CCM, from the Cloud Security Alliance, is a widely recognized framework specifically for cloud security.
CSA CCM.
Got it. It maps cloud security control objectives and controls to other security standards, helping organizations understand the security risks and controls necessary in the cloud. It provides a detailed list of cloud security controls that cloud vendors can implement and that customers can use to assess the security offerings of providers.
A cloud-specific checklist.
Essentially. Then there's ISO 27007, another one from the ISO 27000 family that is specifically relevant to cloud security. It's a companion standard that provides additional guidance for implementing the controls found in ISO 27002, specifically within the context of cloud computing.
So 27002 guidance, but with a cloud focus.
Exactly. It offers advice for both cloud service providers and cloud service customers on cloud-specific aspects of information security.
What about ISO 27018?
ISO 27018 is distinct because it defines new controls and guidelines specifically for protecting personally identifiable information, PII, within public cloud environments.
Focused on privacy and personal data.
Yes. It's crucial for organizations dealing with sensitive personal data as it provides specific recommendations for privacy-related controls beyond general security. It's focused on the provider's obligations as a processor of PII.
Okay, so those help with controls and privacy. What about frameworks or patterns that help you design and build secure things in the cloud?
That's where cloud design patterns and architectural frameworks come in. They offer reusable solutions and best practices for common challenges encountered when designing and implementing applications and systems in the cloud.
Best practices for building stuff securely.
Right. This includes fundamental security design principles, such as those from SANS, emphasizing concepts like defense in depth,
Multiple layers of security.
least privilege,
Only the minimum necessary permissions.
and continuous monitoring, constantly watching for suspicious activity. Applying these principles from the start is crucial for building secure cloud applications.
Building security in, not bolting it on.
That's the goal. Major cloud providers often offer their own architectural guidance, like the well-architected framework. These frameworks typically define pillars for building robust systems, including security, but also operational excellence, reliability, performance efficiency, and cost optimization. They guide you through designing your cloud architecture based on best practices for that specific provider's platform.
So provider-specific guides, too.
Yes. The CSA Enterprise Architecture also provides a framework for securing cloud services at an organizational level, covering domains like governance, data security, operations, and architecture design. Using these patterns helps you build security into the design phase.
And finally, risk frameworks. These seem essential given the shared responsibility model in the cloud.
Absolutely. Risk management is paramount in the cloud, and risk frameworks provide a structured process for identifying, assessing, treating, and monitoring risks.
Which one should we know?
Well, there's the international standard ISO 31000, which provides general principles and guidelines for risk management across any type of risk. While not specific to cloud, its principles apply.
Okay, a general one.
Organizations like ENISA, the European Union Agency for Cybersecurity, provide specific reports and recommendations on cloud security risks. The CSA's work, including the CCM, is also deeply intertwined with cloud risk management, helping assess provider risk.
The CSA covers risk, too.
Definitely. In the U.S., the NIST Risk Management Framework, RMF, is a comprehensive guide used widely by government agencies and increasingly in the private sector. It provides a detailed multi-step process for managing security and privacy risks, which is highly applicable to cloud systems.
NIST RMF, okay.
And again, major providers like Microsoft integrate risk guidance into their offerings through tools and frameworks like the Azure Security Benchmark, which helps customers assess and improve their security posture based on industry standards, including risk management principles. These frameworks give you the structure to proactively address the dynamic risk landscape of the cloud.
We've touched on it multiple times, but it's worth emphasizing again. Moving to the cloud is a strategic business decision. A significant part of that decision-making process involves a cost-benefit analysis.
This is where the rubber meets the road for the business owner. They need to understand the financial implications and operational advantages of shifting to a cloud model compared to maintaining everything in-house. The financial model changes significantly.
How so?
Well, a primary driver is pay-per-usage or consumption-based pricing. Instead of buying a server that sits idle much of the time, you pay only for the computing resources, storage, or network traffic you actually consume, often measured by the second or hour.
Only pay for what you use.
Exactly. This can lead to significant cost efficiencies, especially for variable workloads, as you avoid the large upfront investment in hardware.
And this leads to the CapEx OpEx shift.
Yes. This shift from consumption-based pricing feeds directly into the change from CapEx to OpEx. Capital expenditures, CapEx, are large, infrequent purchases of physical assets like servers and software licenses, which are depreciated over time. Operational expenditures, OpEx, are ongoing costs for services and utilities.
Buying versus renting, basically.
That's a simple way to put it. Cloud computing fundamentally shifts IT spending from CapEx to OpEx, moving from buying assets to subscribing to services. This can improve cash flow, reduce the need for large capital budgets, and provide greater financial flexibility.
What about depreciation?
Related to hardware purchases, depreciation. In a traditional environment, your physical hardware depreciates in value and eventually needs costly replacement. In public cloud, the provider owns the infrastructure, so the customer eliminates the depreciation costs and the burden of hardware refreshes.
Unless you build your own private cloud.
Right. This isn't the case if you're building your own private cloud with your own hardware, of course.
And data center costs.
The elimination or significant reduction of data center and utility costs is another major financial benefit for public cloud users. You no longer need to build, maintain, power, cool, and secure physical data centers. The provider handles all of that.
You just get the bill for the service.
Exactly. You just pay for the resources consumed from their facility. Providers also achieve economies of scale through resource pooling.
We talked about that earlier.
By aggregating resources and serving many customers, they can often acquire hardware, software, and bandwidth at lower costs per unit than an individual organization could. These savings can, in turn, be passed on to the consumer, potentially making cloud services cheaper per unit of resource than self-hosting.
What about software? Does licensing change?
Software licensing is another area of significant change. Many software vendors offer cloud-friendly licensing models, often subscription-based, which align well with the OpEx model and can be scaled up or down with usage.
But there's a catch.
There can be. The material offers a crucial cautionary note here. Sometimes, simply taking an existing software license designed for on-premise use and trying to run it in the cloud, a lift and shift.
Just moving it as is.
Right. That can actually result in higher licensing costs than it did in your own data center. You need to carefully examine cloud-specific licensing options and costs for your software. Don't assume it's automatically cheaper.
Good warning. What about people costs? Personnel.
A potentially very large area of cost saving is personnel and operational costs. With the provider managing the physical infrastructure, patching operating systems in PASA, handling maintenance and ensuring uptime, organizations can potentially reduce the size of their internal IT teams dedicated to these tasks.
So you might need fewer sysadmins.
Potentially. However, and this is another critical caution highlighted, it would be a major mistake to eliminate all your in-house IT and security expertise.
Don't fire everyone.
Please don't. While you might shift roles, you still need skilled personnel to manage your cloud environment, oversee the provider, ensure configurations are secure, manage your data and applications, handle security incidents, and ensure compliance.
You need someone to manage the manager, basically.
Exactly. If you lose all internal expertise, you have no one who truly understands your needs or can effectively manage the provider relationship, potentially leading to paying more for services you don't fully understand or failing to manage your security and compliance obligations effectively. The shift is often about focusing existing personnel on higher value activities rather than simply reducing headcount to zero.
Okay, shifting focus, not just cutting.
Which leads to the final benefit, a shift in focus. By offloading the undifferentiated heavy lifting of infrastructure management to the provider, organizations can redirect their internal resources, including skilled personnel, towards strategic business initiatives, application development, innovation, and activities that directly differentiate them in the market.
Freeing up people to do more valuable work.
That's the potential benefit. This refocusing can potentially lead to increased productivity, faster time to market for new services, and business growth.
That detailed look at the cost-benefit analysis shows it's not just about comparing sticker prices, but fundamentally changing the financial and operational model. Once a business has decided the cloud is the right path and identifies potential service providers, how do they evaluate these services and build trust in their security and capabilities? The source material discusses evaluation criteria.
Evaluation criteria provide an independent, objective way to assess products and services, including cloud offerings. The purpose is to give consumers confidence in the capabilities and security of what they are purchasing, based on testing by an impartial third party, not just marketing claims.
Independent verification.
Exactly. The typical process involves a vendor submitting their product or service to an independent testing laboratory. The lab evaluates it against a specific set of criteria and produces a report and a rating. Customers can then review these independent findings to inform their purchasing decisions.
Okay, what is this?
There are two main steps in this formal evaluation process: certification and accreditation.
Certification first.
Certification is the first step. This is the formal technical evaluation of a product or service by the independent testing lab. They conduct a thorough analysis to verify that the product meets the specified technical requirements and security properties. This is where the testing happens and the rating is assigned.
What criteria do they use?
A widely used set of international criteria for evaluating IT security products is the Common Criteria for Information Technology Security Evaluation, often simply called Common Criteria.
Common criteria, okay.
It's used globally to evaluate a wide range of security-enabled products, from operating systems and firewalls to smart cards and, yes, cloud infrastructure components.
How does the rating work?
When a product is evaluated against common criteria, it receives an Evaluation Assurance Level, EAL, rating. EALs range from 1 to 7, with EAL1 being the lowest level of assurance, basic functional testing, and EAL7 being the highest, formal design verification and testing, very rigorous.
So higher EL means more rigorous testing.
Yes. A higher EAL indicates more confidence in the product's security functions based on a deeper and more rigorous evaluation process.
Are there other criteria besides common criteria?
Another important set, particularly for evaluating cryptographic modules, is FIPS 142, or the updated 143.3. FIPS stands for Federal Information Processing Standards, and the standard is used in the US and Canada to validate the security of cryptographic modules, the hardware or software components that perform encryption and decryption, like hardware security modules, HSMs, or modules within operating systems.
So specifically for crypto stuff.
Exactly. FIPS 140 defines 4 security levels, from 1 to 4. Level 1 is the lowest and simply requires the module to be a production-grade working cryptographic module.
Okay, basic crypto.
Level 2 adds requirements for physical tamper evidence, you can tell if someone tried to open it, and role-based authentication. Users must authenticate to perform specific cryptographic roles.
Show signs of tampering.
Right. Level 3 significantly increases the security requirements. It demands physical tamper resistance, the module actively protects its keys if tampered with, and identity-based authentication. Authentication is tied to a specific user identity, not just a role.
Harder to tamper with, better authentication.
Yes. Level 4 is the highest, providing robustness against environmental attacks and requiring the module to be functional and secure even under extreme conditions. A key takeaway is that FIPS Level2 and higher introduce physical security requirements, meaning the module must have some physical protection against tampering, increasing with each level.
Physical protection matters for FIPS.
For Level 2 and up, yes. So, certification is the technical thumbs up from the independent lab using criteria like common criteria, giving an EAL, or FIPS 140, giving a level.
What's the second step? Accreditation.
Right. The second step is accreditation. This is the formal decision by your organization's management to accept the certified product or service and authorize its deployment and use within your environment for a specified period.
So management signs off.
Exactly. Based on the certification report, your internal assessment of risk, and your organization's specific requirements and risk appetite, management makes the ultimate go-no-go decision. It's the official acceptance for use.
That structured evaluation process certainly seems necessary when you're entrusting critical data or systems to a provider. It provides a basis for building trust. Now, putting all this together, the characteristics, the roles, the models, the shared considerations, the evaluation criteria, it becomes clear that moving to the cloud fundamentally changes the risk landscape. You're still accountable for security, but much of the control and management is delegated. This brings us to risk management. Why is risk management so vital and distinct in the cloud context?
Risk management is essential in any security program, but it becomes particularly complex and critical in the cloud environment precisely because of that dynamic. You remain accountable for protecting your assets, but the physical infrastructure and many operational controls are managed by a third party.
Right. That accountability versus delegated responsibility thing again.
Exactly. You have to manage risk in an environment you don't fully control yourself, often with limited visibility into the provider's internal operations, all while facing budget and time constraints.
So what's the goal of risk management in the cloud?
The purpose of a robust risk management process in the cloud is to systematically identify, assess, and prioritize the security risks to your assets when they are in the cloud. This allows you to allocate your limited resources, budget, personnel, time to the most critical risks.
Focus on the biggest dangers.
Right. It helps you determine what security controls are necessary, where responsibility lies, provider or consumer, and how to gain assurance that those controls are being implemented and operated effectively, especially by the provider.
Before we get into the process, there are some terms about risk tolerance.
Yes, quickly. An organization has a risk profile, which is a comprehensive view of the types and levels of risk it faces, its overall risk capacity, how much risk it can handle, and its preferences regarding risk-taking. This profile helps guide all risk-related decisions.
The overall picture of risk for the company.
Within that, risk appetite is the overall amount and type of risk an organization is willing to accept in pursuit of its strategic objectives. It's a high-level statement of how much risk the organization is willing to take on to achieve its major goals.
How much risk for the big picture goals.
And risk tolerance is a more specific concept. It's the amount and type of risk an organization is willing to accept in pursuit of specific operational objectives or for a particular project.
How much risk for a specific task or goal?
Exactly. For instance, a company might have a high-risk appetite for launching innovative, potentially disruptive services, but a very low-risk tolerance for anything that might impact customer data privacy.
Got it. Profile, appetite, tolerance. Now, the risk management steps.
At a high level, risk management involves 3 major steps: asset valuation, risk analysis, and treatment.
Okay, step 1, asset valuation. What's that about?
The first step is understanding what you're trying to protect and how important it is. Asset valuation is the process of assigning a value or ranking to each asset. Your data, applications, systems, infrastructure, reputation, to understand their importance to the organization.
Figure out what matters most.
Right. The idea is simple. You can't effectively protect everything equally, so you need to know which assets are most critical so you can prioritize protecting them. In practice, however, valuing certain assets, like reputation or intellectual property, can be very difficult.
How do you put a price tag on reputation?
Exactly. That's the challenge. There are 2 main methods for valuation. Quantitative analysis attempts to assign a specific monetary value to each asset.
Putting a dollar figure on it.
This is the preferred method because it provides a concrete financial figure that can be used in cost-benefit analyses for security controls. However, accurately assigning a dollar value to things like customer trust, brand reputation, or proprietary algorithms is often impossible, making this method hard to apply comprehensively.
So what's the alternative?
Because quantitative valuation is so challenging for many critical assets, the most common method used is qualitative analysis. This involves assigning a relative ranking to assets, such as high, medium, or low value.
High, medium, low.
By comparing them to each other based on subjective criteria like their criticality to business operations, the sensitivity of the data they hold, or the potential impact of their loss. It's less precise than quantitative analysis, but is much more feasible to implement. While not perfect, a qualitative ranking is far better than having no understanding of which assets are most critical.
Better than nothing. Okay, step 2, risk analysis.
Once you know what assets are most valuable, you identify the risks associated with those assets. To fully understand any given risk, you need to examine 4 components: threats, vulnerabilities, likelihood, and impact.
Threats, vulnerabilities, likelihood, impact. Okay.
Threats are potential sources of harm, events, situations, or actions that could damage or compromise an asset. Threats can be malicious, cyber attacks, insider theft, accidental human error, system failure, or environmental, natural disasters like floods or earthquakes.
What could go wrong?
Essentially. Understanding the threats relevant to your cloud assets is crucial. Threat modeling methodologies, such as Stride or PASTA, can help you systematically identify and prioritize potential threats to your cloud systems and applications.
What about vulnerabilities?
Vulnerabilities are weaknesses or gaps in your security controls or system configurations that a threat could exploit. These are the doors left unlocked, the unpatched software, the misconfigured firewall rules.
The holes the threats can get through.
Exactly. Techniques like vulnerability assessments and penetration testing are designed to identify these weaknesses in your systems and configurations within the cloud environment, though executing these against the provider's infrastructure has specific rules and considerations.
Okay, then likelihood and impact.
Likelihood, or probability, is the estimated chance or frequency that a specific threat will successfully exploit a particular vulnerability. Is this attack likely to happen daily, yearly, or once a decade?
How often might it happen?
An impact is the magnitude of potential harm or damage that would occur if the risk materializes. This could be financial loss due to downtime, data recovery fines, operational disruption, reputational damage, legal consequences, or loss of life.
How bad would it be if it happened?
Right. After identifying threats, vulnerabilities, likelihood, and impact for key assets, you need to rank the risks to determine which are of greater concern. Again, you can attempt a quantitative or qualitative ranking.
How does quantitative risk ranking work?
Quantitative risk ranking attempts to calculate the expected annual cost of a risk, often referred to as the annualized loss expectancy, or ALE.
ALE.
The formula is ALE equal SLE x ARO. If you can accurately calculate ALE, it's a powerful tool for justifying security investments, as you can show that the cost of implementing a control is less than the expected cost of the risk occurring.
Sounds useful, but maybe hard to calculate. What's SLE and ARO?
Good question. SLE is the single loss expectancy, the estimated monetary cost if the risk event occurs just once. You calculate SLE as asset value x exposure factor.
Asset value, we talked about exposure factor.
The exposure factor is a percentage representing the proportion of the asset's value that you expect to lose if the risk occurs. If a fire destroys half a building worth $1 million, the exposure factor is 50%, and the SLE is $500,000.
Okay, percentage of loss.
ARO is the annualized rate of occurrence, the estimated number of times per year you expect the risk event to occur. If you anticipate a specific type of malware infection happening roughly every 6 months, your ARO would be 2, twice a year.
How often it happens per year?
So you multiply the cost of one incident, SLE, by the expected number of incidents per year, ARO, to get the estimated annual cost of that risk, AR. While the formula itself is simple, the accuracy of the ALE depends entirely on the accuracy of the input values, asset value exposure factor, ARO.
Which are hard to pin down.
Which, as we've noted, are often incredibly difficult to estimate precisely, particularly for cloud-specific risks or non-monetary impacts.
So qualitative ranking is more common here too.
Consequently, yes. Similar to asset valuation, most organizations rely on qualitative risk ranking. This involves combining the qualitative assessment of likelihood, for VANCHI high, medium, low, with the qualitative assessment of impact, VARIGI high, medium, low, to assign an overall risk level, FAIGI high, medium, low risk, to each identified risk.
High likelihood plus high impact, high risk.
Exactly. A risk that is highly likely to occur and would have a high impact is ranked as high risk. One that is unlikely with low impact is low risk. It's a relative ranking that helps prioritize risks even without exact dollar figures.
Okay, makes sense. That brings us to step 3, treatment. What do we do about the risks?
Once you've identified, analyzed, and ranked your risks, the final step is deciding what to do about them. There are 4 main risk treatment methods: avoid, transfer, mitigate, and accept.
Avoid, transfer, mitigate, accept. Let's start with avoid.
To avoid a risk means to prevent it from occurring entirely by eliminating the source of the risk or choosing not to engage in the activity that creates the risk. For instance, if you want to avoid the risk of physical data center damage from a hurricane, you avoid building your data center in a hurricane-prone area.
Or the parachute example.
If you want to avoid the risk of a fatal outcome from jumping out of an airplane, you simply choose not to jump. You avoid the activity. Stop doing the risky thing.
Okay. What about transfer?
To transfer a risk means to shift the financial burden of the risk to a third party. The most common way to do this is by purchasing insurance.
Buying insurance.
Right. If a disaster occurs, like a fire in your cloud provider's data center affecting your systems, your insurance policy might cover the financial losses. However, this is a critical point and worth repeating. You can never transfer or delegate accountability for the risk itself.
Can't transfer accountability.
Never. Buying insurance transfers the financial consequence, but you are still accountable to your stakeholders, customers, and regulators for the security and availability of your data and systems.
Got it. Financial transfer, not accountability transfer. Next is mitigate.
To mitigate a risk means to implement controls or safeguards to reduce the likelihood of the risk occurring or lessen the impact if it does.
Right.
This is what security professionals spend most of their time doing: building defenses.
Putting controls in place.
Yes. When you implement mitigating controls, you reduce the risk, but you rarely eliminate it entirely. The risk that remains after you have implemented controls is called residual risk.
A leftover risk.
Right. Perfect security is generally unattainable. There will always be some residual risk left over.
How do we implement these mitigating controls?
We categorize mitigating controls into 3 major types based on their implementation method. Administrative controls.
Policies, procedures, training.
Things that direct or guide human behavior or organizational processes. Technical or logical controls.
Firewalls, encryption, logins.
Technology-based controls. and physical controls.
Fences, locks, cameras.
Exactly. Controls related to physical security, like fences, locks, security guards, surveillance cameras, environmental controls like fire suppression systems or HVAC.
Admin, technical, physical. Are there other ways to categorize controls?
We can also categorize controls based on their function in addressing a risk, thinking about them as either safeguards, aiming to prevent the risk from occurring, or countermeasures designed to detect and respond if a risk has occurred.
Safeguards try to stop it, countermeasures react to it. Okay, what types of safeguards?
Within safeguards, we have directive controls, which mandate or guide specific actions or behaviors, like a security policy saying all employees must use strong passwords. We have deterrent controls, which discourage undesirable behavior but don't physically prevent it.
Like a warning sign.
Like a sign saying trespassers will be prosecuted. Or, using that analogy, comparing different approaches to gun control, one might focus on prevention, another on deterring misuse with penalties. A deterrent makes someone think twice but doesn't physically stop them.
Makes sense. And preventative.
And we have preventative controls, which are designed to stop a risk from occurring, like a firewall blocking malicious traffic, or a strong authentication mechanism preventing unauthorized login.
Here.
These try to physically block the bad thing.
Okay. Directive, deterrent, preventative. Now, countermeasures, the reactive ones.
Within countermeasures, we have detective controls, which identify a risk event that is occurring or has already occurred.
Like alarms, SIEMs, IDs.
Exactly. An intrusion detection system alerting on suspicious activity, or a smoke detector signaling a fire. We have corrective controls, which aim to reduce the negative impact after a security incident.
Like putting out the fire.
Like a fire suppression system putting out a fire that a smoke detector detected. We have recovery controls, which help restore systems and operations after a disruptive event.
Like a disaster recovery plan.
Exactly. A disaster recovery plan or business continuity plan. And finally, compensating controls.
What are those?
Compensating controls are put in place to provide an alternative or supplementary measure when a required or preferred control cannot be fully implemented or is ineffective. For example, if you can't apply security patches to a critical legacy system without breaking it.
A common problem.
Right. A compensating control might be to place a strict firewall around that system to limit network access, significantly reducing the likelihood of exploitation, even though the vulnerability still exists. It makes up for a weakness elsewhere.
Okay, a backup control. What makes any of these controls good?
Finally, any good control, regardless of type, needs two aspects: functional and assurance. The functional aspect is simply what the control is supposed to do. For example, a firewall's function is to filter network traffic.
Just do the job.
And the assurance aspect is your ability to gain confidence on an ongoing basis that the control is actually working correctly and effectively performing its function. Checking firewall logs, running periodic tests, monitoring its performance.
Can you prove it's doing the job?
Exactly. You need both for a control to be effective.
Okay, so that's mitigation, implementing controls. What's the final treatment method?
Yeah.
Accept.
The final treatment method is to accept the risk. This is a deliberate, informed decision to take no further action to reduce the risk, accepting the potential consequences if it occurs. This is typically done for risks that are low likelihood, low impact, or where the cost of mitigation outweighs the potential impact.
Deciding to live with the risk.
Yes. But crucially, who should accept the risk?
Let me guess. The accountable party.
The asset owner. Because they are accountable for the asset, they are the only ones who can make the business decision that the remaining risk, the residual risk after controls are applied, is acceptable to the organization based on the potential impact versus the cost or feasibility of further mitigation. This decision should be documented.
Wow, that was an incredibly thorough exploration of the foundational elements of cloud security. We really went deep into what cloud computing is, not just a simple definition, but its key characteristics: on-demand self-service, broad network access, resource pooling enabled by virtualization, rapid elasticity, and measured service, and the nuance of multi-tenancy.
We covered a lot of ground there, defining what makes cloud, well, cloud.
We broke down the essential roles involved, focusing heavily on that absolutely critical distinction between accountability and responsibility, and how the shared responsibility model shifts the security burden, but not the ultimate ownership of risk. We looked at the intermediaries with the broker models and the specific functional roles in the cloud ecosystem.
Understanding who does what, and especially who remains accountable, is just fundamental.
Then we covered the different ways cloud is delivered and structured through service models: IS, PINUS, SAWs, and their nuances, and deployment models, public, private, community, hybrid, multi-cloud. We discussed the crucial shared considerations you absolutely must evaluate before moving to the cloud, like portability, reversibility, and regulatory compliance, recognizing that cloud adoption is fundamentally a business decision.
Yeah, thinking about those considerations up front can save a world of pain later.
We explored the frameworks that provide structure and guidance for security, design, and risk management in the cloud, including ISO 27001, CSA-CCM, ISO 27017, and FIPS, and touched on design patterns and risk frameworks. We delved into the business side with the cost-benefit analysis, looking at the shift from CapEx to OpEx, personnel costs, and licensing, along with the critical cautions there. And we learned how to evaluate cloud services using formal criteria like Common Criteria, EALs, and FIPS 140 levels through certification and accreditation.
Using those frameworks and evaluation criteria helps build trust and manage complexity.
Finally, we wrapped up with a detailed look at risk management valuing assets, quantitatively versus qualitatively, analyzing risks by understanding threats, vulnerabilities, likelihood, and impact, attempting the tricky quantitative analysis with ALE, SLE, XARO, and using qualitative methods, and then deciding on risk treatment. Avoid, transfer, remember you can't transfer accountability. Mitigate, using administrative, technical, physical controls, and categorizing them as safeguards or countermeasures, including compensating controls. And finally, accept the residual risk, always by the asset owner.
Yes, mastering these fundamental concepts, the models, the shared responsibility dynamics, the unique considerations of the environment, the structured approaches offered by frameworks, and the systematic process of risk management is truly the essential groundwork.
It really sets the stage.
It provides the necessary clarity to navigate the complexities of securing assets and operations in environments you don't fully control, ensuring you can make informed security decisions that align with business goals and compliance requirements.
Exactly. It's about having that solid understanding beneath your feet so you can approach cloud adoption or cloud security management from a position of knowledge and confidence.
This raises an important question, though. Given the unprecedented pace of innovation and the continuous introduction of new services and capabilities by cloud providers, often accessible via self-service.
Yeah, things change so fast.
How can organizations ensure their foundational governance, risk management, and security practices remain effective, agile, and comprehensive enough to address the security implications of this ever-evolving landscape without becoming a bottleneck to business agility?
That's a truly fascinating challenge to consider. How do you build processes that are both rigorous enough to manage complex security risks and flexible enough to keep up with the speed of cloud evolution? How do you stay ahead of the security curve when the technology curve is accelerating so rapidly? Something to definitely ponder as you think about these foundational cloud security concepts.
It's a continuous balancing act.
Thanks for joining us. We hope this extensive exploration has given you a much clearer and more insightful picture of the essential building blocks for cloud security.